Hey there, math enthusiasts! Ready for a wild ride through the world of numbers? Buckle up! Numbers are everywhere around us. They're like the alphabet of mathematics. Just as we use letters to form words, we use numbers to understand the world. When you wake up, what's the first thing you do? Check the time, right? That's numbers in action. When you head to school, you might notice the speed limit signs. Yep, numbers again. But numbers aren't just for counting things. They have their own special properties and relationships. So, are you ready to dive deeper into the fascinating world of numbers? Let's start by getting to know some of the different types of numbers we'll be working with. Let's kick things off with the most basic division in the number world, even and odd numbers. These two categories form the foundation of many mathematical concepts and are essential for understanding more complex ideas. Even numbers can be divided equally into two groups. This means that when you split an even number, there are no leftovers, making it perfect for fair sharing. If you have an even number of cookies, you can always split them fairly. Imagine having 10 cookies. You can give 5 to one person and 5 to another without any issues. Odd numbers, on the other hand, always have a little bit left over. This leftover makes odd numbers unique and sometimes a bit tricky to deal with. If you have an odd number of cookies, there's always going to be that one cookie that causes a fight. For instance, with 7 cookies, you can give 3 to one person and 3 to another, but that one extra cookie can cause a dispute. Here's a cool trick. You can tell if a number is even or odd just by looking at its last digit. This simple method can save you time and effort. If the last digit is 0, 2, 4, 6, or 8, it's an even number. This rule applies to any number, no matter how large. If it ends in 1, 3, 5, 7, or 9, it's odd. This makes it easy to quickly categorize numbers without doing any complex calculations. This works because even numbers are always divisible by 2, while odd numbers always leave a remainder of 1. This fundamental property is what distinguishes them. In computer programming, for example, even and odd properties are used all the time. Programmers often use these properties to optimize code and solve problems efficiently. So next time someone tells you math isn't practical, you can wow them with your even and odd knowledge. Whether in everyday life or in specialized fields, understanding these basic concepts can be incredibly useful. Now let's talk about the VIPs of the number world, prime numbers. These are the special numbers that only have two factors, 1 and themselves. The smallest prime number is 2. It's also the only even prime number. And then we have 3, 5, 7, 11, 13, and so on. Prime numbers are like the building blocks of all other numbers. Just like how you can build any Lego structure using basic Lego bricks, you can create any number by multiplying prime numbers together. This is called prime factorization, and it's a super important concept in math. For example, 12 can be broken down into 2 times 2 times 3. Mathematicians have been trying to find patterns in prime numbers for centuries, and they're still discovering new things. Prime numbers aren't just mathematical curiosities. They're used in cryptography, which is the science of coding and decoding messages. So next time you're shopping on the internet, give a little thank you to those hard-working prime numbers. Now that we've met the solo artists of the number world, let's look at some number relationships. First up, we have coprime numbers. These are pairs of numbers that don't have any common factors other than 1. For example, 14 and 15 are coprime. The factors of 14 are 1, 2, 7, and 14, while the factors of 15 are 1, 3, 5, and 15. Coprime numbers are super useful in many areas of math, especially in fractions. When you're simplifying fractions, you're looking for numbers that aren't coprime so you can cancel them out. Now let's talk about a special kind of prime number relationship, twin primes. These are pairs of prime numbers that are only 2 apart. Some examples are 3 and 5, 5 and 7, 11 and 13, and 17 and 19. Twin primes might seem like just a fun mathematical curiosity, but they actually have some real-world applications too. They're used in some methods of generating random numbers, which is important in things like computer simulations and cryptography. Section 5. Composite numbers, the mix and match gang. Now, let's meet the opposite of prime numbers, composite numbers. These are the social butterflies of the number world. While prime numbers only have 2 factors, 1 and themselves, composite numbers have at least one more factor. Any number that isn't prime, except for 1, which is neither prime nor composite, is composite. The number 4 is composite because it has factors 1, 2, and 4. The number 6 is composite with factors 1, 2, 3, and 6. And 12, it's a super social composite number with factors 1, 2, 3, 4, 6, and 12. Composite numbers are built by multiplying smaller numbers together, hence the name composite. When you're arranging things in rows and columns, you're working with composite numbers. Section 6. Factors and multiples, breaking down and building up. Now let's dive into the world of factors and multiples. A factor is a number that divides evenly into another number. For example, the factors of 12 are 1, 2, 3, 4, 6, and 12. Multiples, on the other hand, are what you get when you multiply a number by whole numbers. The multiples of 3, for instance, are 3, 6, 9, 12, 15, and so on. To find the factors of a number, start from 1 and work your way up, checking which numbers divide evenly. But you only need to check up to the square root of the number. Understanding factors and multiples can be super helpful in real life. Need to divide things evenly among people? Factors can help. Planning a schedule where events repeat at regular intervals? That's all about multiples. Section 7. Divisibility Tests. Quick number tricks. All right, math detectives, it's time to learn some quick tricks for figuring out if one number divides evenly into another. These tricks can make your math life a lot easier and faster. These are called divisibility tests, and they're like secret codes that numbers leave behind. Once you know these codes, you can crack the mystery of divisibility in seconds. For divisibility by 2, just look at the last digit. If it's even 0, 2, 4, 6, or 8, the whole number is divisible by 2. This is one of the simplest tests and can be used almost instantly. For divisibility by 5, the last digit needs to be either 0 or 5. This trick is especially handy when dealing with larger numbers. For 10, it needs to end in 0. This is a straightforward test that can save you a lot of time when working with big numbers. For divisibility by 3 or 9, add up all the digits. If that sum is divisible by 3 or 9, so is the original number. This trick is a bit more involved but very useful for quick calculations. For divisibility by 4, just look at the last 2 digits. If that 2-digit number is divisible by 4, so is the whole number. This is particularly useful for larger numbers where you need a quick check. These divisibility tests aren't just party tricks. They're actually super useful in all sorts of situations. Whether you're doing homework, taking a test, or just solving everyday problems, these tricks can come in handy when you're simplifying fractions, checking if a number is prime, or solving more complex math problems. Being able to quickly determine divisibility can save you a lot of time and effort. So, keep these tricks in your math toolkit, and you'll be solving problems faster and more efficiently. Section 8. LCM. Finding the lowest common multiple. The LCM of 2 or more numbers is the smallest number that is a multiple of all of them. It's a fundamental concept in mathematics that helps us understand how different numbers relate to each other. For example, the LCM of 4 and 6 is 12, because that's the smallest number that both 4 and 6 can divide into evenly. This means 12 is the first number that appears in both the sequence of multiples of 4 and 6. Ever had to figure out when 2 events that happen at different intervals will occur at the same time? That's an LCM problem. For instance, if one event happens every 4 days and another every 6 days, they will both happen together every 12 days. So how do we find the LCM? There are a few methods, but one of the easiest is to list out the multiples of each number until you find the first one they have in common. This method is straightforward and works well for smaller numbers. Let's try it with 3 and 4. Multiples of 3, 3, 6, 9, 12. And multiples of 4, 4, 8, 12. Aha! 12 is the first number that appears in both lists. So that's our LCM. This method is visual and helps in understanding the concept better. But what if we have larger numbers? Listing out multiples can become tedious. That's where more efficient methods come in handy. For larger numbers, there's a more efficient method using prime factorization. This method involves breaking down each number into its prime factors. You break down each number into its prime factors, take each factor to the highest power it occurs in either number, and multiply these together. This gives you the LCM in a more systematic way. Understanding LCM isn't just about solving math problems, It's about seeing the hidden patterns that connect numbers in fascinating ways. It helps us appreciate the beauty and order in mathematics, making it a powerful tool in problem solving and logical thinking. Section 9. HCF, the highest common factor. The HCF of two or more numbers is the largest number that divides evenly into all of them. Let's look at an example. What's the HCF of 12 and 18? The factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 18 are 1, 2, 3, 6, 9, and 18. The common factors are 1, 2, 3, and 6. The largest of these is 6, so that's our HCF. The HCF is super handy when you need to divide things equally into the largest possible groups. Imagine you have 12 red balloons and 18 blue balloons, and you want to make the largest possible bouquets with an equal number of each color. The HCF tells you that you can make 6 bouquets, each with 2 red and 3 blue balloons. Cool, right?